going to start talking about how to analyze graphs, so basic graphical analysis. And the underlying idea is that whenever we have data graphed, we want to ultimately manipulate it into a straight line. So eventually we want a graph that gives us a nice straight line relationship so that we can take it and write an equation for it in the form y equals mx plus b. But like we talked about in a previous video, if we're graphing, for example, let's just say height versus age, then we would write something like height equals some slope times age plus some intercept. So the slope goes right next to the x value, which is the age, and then the y value is the height. And we talked about this in a prior video. So the first step in figuring out the equation y equals mx plus b is look at the data and determine, do we already have a straight line? And if I started with a graph that looks like this, then the answer is yes, and I can use methods to calculate the slope and the intercept and immediately put it into a y equals mx plus b form. But it might not be that simple. I might have some sort of a graph where it doesn't look like a straight line. For example, let's say I have a graph of your grade, so how well you do on a test, for example, versus the number of hours of sleep. Okay, so this is going to be hours of sleep, and this is going to be your grade on a test. Okay, so maybe that's in points or whatever. So it's grade versus sleep. And let's say that this graph looks something like this, which seems to say that there's not a linear relationship between the hours of sleep you get and your grade on a test. So if you get a lot more sleep, then your grade on a test goes way up. So that's not linear. The question that we have to ask is, what is it? Is it a parabola? Is it like a square root? Is it like an inverse function? And what equations are usually associated with those types of graphs? So we're trying to play the matching game. And we'll see ways to do this more precisely with Microsoft Excel or other programs in the future. But for right now, it's kind of a guess and check game. Okay, so in our example, we could say, alright, does this look kind of like a square root graph? So this is like grades and sleep, and it's like grade is equal to some constant times the square root. In other words, y equals k square root of x. Is this some sort of, I don't know, an inverse function that goes kind of like this, where instead of saying y is equal to k over x, we could say, grade on a test is equal to k over hours of sleep. So the more sleep you get, the lower your grade. Does that make sense? Probably not. I think what we're probably dealing with is something that looks like y equals k x squared. So you have grade here and sleep here. So we have grade is equal to k times sleep squared. And that looks kind of like a parabola. So that's what we have. Okay, so now how do we turn this into a straight line? So you probably have a data table, and your data table probably has something that has to do with the hours of sleep you have. Those would be your x coordinates, and then you have g, the grade. Okay, so I'm just going to make this up. Let's say 1 hour of sleep gets you 10 points. 2 hours of sleep gets you 40 points. 3 hours gets you 90, and 4 hours of sleep gets you 160. You can see the trend here. It's just square the hours of sleep and multiply it by 10. Okay, so what I want to do is I actually want to square the hours of sleep. So instead of sleep in hours, I'll have sleep squared in hours squared. So that'd be 1 and 4 and 9 and 16. And now what I do is I take this new data. So I take this and I'm going to put sleep squared in units of hours squared on the x-axis, and then I'm going to plot grade, and that's still measured in points, on the y-axis. Okay, so let's try and make this realistic. One thing I want to avoid is I don't want to put 1, 4, 9, and 16. That's not an even scale like we talked about in one of the previous videos. Instead, let's call this 5, 10, 15, and 20. So then the points that we have to plot, and let's do the other axis too. Okay, let's say that this is 40, 80, 120, and then 160 is up here. You get the idea. Okay, so the points that we want to plot is 1 and 10, which is going to be maybe here. Okay, and then we're going to have 4 and 40, which is like here. We're going to have 9 and 90, which is approximately here. And we're going to have 16 and 160, which is all the way up here. So you can see that when we plot the hours of sleep squared versus the grade, it turns into a straight line. Okay, so this is grade is equal to some constant times sleep squared. So it's kind of like sleep squared is our new x value. Okay, and instead of writing y equals kx squared, we're doing y equals kx, where x is being played by s squared. Okay, so once you've done this, then you can look at the graph and you can try to determine the slope and you can try to find the intercept. Okay, and hopefully what you can see from this is that the equation would be grade is equal to 10 times s squared. Okay, and the last thing that we need to do is we need to check our units for the slope, because the slope obviously is 10, right? But what are the units for it? Well, the slope is going to have units of grade over units of sleep squared. So it's going to be points per hour squared. And so we would write in our equation 10 points per hour squared times s squared. And if you just heard the bell in the background, yes, I'm recording at school. So we'll continue this in the next video.